How was the world around us formed? How did it evolve to become the Earth as we know it today? The history of the Earth begins 4.6 billion years ago. At that time, everything was different from what we know today. In the beginning, the Earth seemed strange and unknown, and yet it will become so welcoming that it will allow life to develop and man to settle there permanently. Dear traveler, welcome. Through 4 videos, we embark on the history of the Earth since its birth to dive into the heart of our planet, from the beginning of its formation and throughout its evolution. You are here in the 3rd chapter. Previously, we related its adventure from its accretion to 500 million years ago. You will continue this journey until 250 million years before our era. Every planet has a history. This is the history of the Earth. But before leaving for a new adventure, think of liking the video and subscribing to the channel to not miss anything. Thank you, and have a nice trip. The Earth has so far offered a desolate landscape. Lava flows from volcanoes have rolled down its sides. Now immobile, they still crackle but slowly freeze. Lakes of yellow, blue, or gray mud are bubbling. The heat coming from the bowels of the Earth bursts on the surface of these muds in thick bubbles. When the first volcanoes appear on the surface of the Earth, they contract in extraordinarily violent eruptions before cooling down and building gigantic mountains made of ash and lava. Over the years, these rocks evolve into mud and clay under the action of wind and rain. The debris is carried away by torrents and carried to the sea, then accumulates and forms shales and sandstones. At the same time, the continents continuously in motion are moving. When they meet, the surrounding sediments are dragged along and compressed to form new mountain ranges. As geological cycles progress, volcanoes erupt, then die out, and life proliferates on the seafloor. As for the dry land, it remains sterile, until the day when 4 large continents remain: Laurentia, Baltica, Siberia, and Gondwana. They are drifting. Facing Laurentia, the margin of Gondwana begins to crumble into several small continents. The first individualize is Avalonia. Its distance diminishes the Lapitous Ocean and opens the Rick Ocean. This is the beginning of the Caledonian orogeny. From 485 million years, very primitive plants, resulting from association between algae and fungi, come out of the water to settle on rocks in the open air. Adorning with green the edges of the beaches and the rocks, these plants cannot extend. As soon as they go beyond the areas moistened by the spray, they dry out and do not survive. Water does not circulate in their tissues. To face the desiccation, they develop capacities of return to life. They dry out completely and rehydrate themselves as soon as the first rains come to return to life. Other plants develop an impermeable waxy film that reduces their water loss. For the moment, the plants have simple forms with a very primitive vascularization and have no leaves. they are intimately linked to the aquatic environment for their reproduction process. Mosses are among the first plants to colonize dry land. They remain low to the ground, continuously established near the shore, but manage to disperse somewhat. Mosses do not have roots. Their gas exchanges are carried out thanks to stomata, openings which open and close in order to regulate the flow. Deprived of lignin, the tegils of mosses are condemned to remain soft and have no consistency. They only rise when they grow tightly together. Mosses function like sponges. Their water-filled cells are partitioned, and they must stay close to the ground to draw water. Mosses release spores, reproductive corpuscles, onto moist soil, which will allow them to reproduce, either asexually or sexually, on an alternating basis. Sexual reproduction is important in the history of evolution because it requires the meeting and fusion of two sex cells that need a liquid medium to move and join. Each ovum is attached to the top of the stem, while the spermatozoa are released into the water and move until they reach it and fertilize it. The ovule germinates, attached to its mother plant, and produces the asexual generation. A small stem with a capsule at the top with many spores. As soon as the air becomes dry, the capsule grows, opens, and releases the spores, which are scattered by the wind. Spores that fall on moist soil will develop into young plants. Liverworts have appeared alongside mosses. These plants do not have roots, but rhizoids, filaments which fix them solidly to the substrate without allowing them to absorb nutritive elements. The gas exchanges are done thanks to pores, openings which remain fixed. The colonization of dry land by plants is a fundamental step in the history of the Earth because it results in a significant increase in oxygen in the atmosphere and a decrease in CO2. Plants use photosynthesis to produce their own organic matter. They draw on solar energy, extract atmospheric CO2, and release oxygen. The Earth's atmosphere is marked by a second significant increase in its oxygen concentration, the first being the Great Oxidation Crisis. The proliferation of plants on land is the origin of the formation of soils. Before, the surface of the Earth was only mineral, consisting of bare rocks and grains, such as sand and silt. The first plants to occupy the soil emerged, then died and decomposed. Litter and humus were formed, and as a result, new environments were created for the development of other plants, fungi, and animals. The mosses and liverworts spread and form vast green carpets with the appearance of real Lilliputian forests that, starting from the seashore, extend towards the interior of the land. The mainland appears lifeless. The rocky ground is now covered here and there with mosses. The temperature is about 30 degrees Celsius, or 86 degrees Fahrenheit. The ozone layer is thickening, and ultraviolet rays are only partially filtered. For the living, it is better to stay underwater. The sea level is high. Gondwana is located in equatorial latitudes and is moving towards the South Pole. It is partially covered by shallow seas. Its proximity to the pole starts a drop in temperature that will gradually lead to the appearance of glaciers. But during this time, life is in full swing. Oxygen levels reach 2% of the current atmosphere. a level so low that the living beings of our time would have great difficulty in breathing. The gigantic Panthalassa Ocean covers most of the planet. It is at this time that the marine biodiversity will increase in an exceptional way. It is the great biodiversification of the Ordovician. 490 million years ago, the Earth's atmosphere was rich in CO2. The greenhouse effect induced by this gas maintained warm temperatures. Ocean temperatures could rise to 45 degrees Celsius, or 113 degrees Fahrenheit, which is not very favorable to a high level of dissolved oxygen. The development of life helps to absorb and fix CO2 through the process of photosynthesis. 30 million years later, the land cooled, and this cooling was accompanied by an increase in biodiversity. The number of genera of marine animals quadrupled. The ocean becomes an aquatic paradise, populated by creatures, all more extraordinary than the others. The water of the ocean is enriched in oxygen, which allows some animals to reach considerable sizes. The development of plankton favors the appearance of a great diversity of benthic fauna. Organisms secreting carbonate-based shells appear in mass, such as cephalopods, crinoids, and articulated brachiopods. Coral reefs develop. The first ectoprocts arrive, and mollusks become common. In the middle of these warm and sunny waters, trilobites of 60 centimeters or 24 inches long wander in search of food, plankton, pieces of algae, or animal droppings, sucking up the ocean floor. They share the waters with a brand new roommate, the astraspis, a primitive species of fish. Despite its small size, which does not exceed 15 centimeters or 6 inches, the astraspis has for the first time a primitive backbone and the existence of a bony carapace that protects the spine. It is the ancestor of the future living beings of the planet Earth. Astraspis is not a predator. It feeds on algae and microbes. It does not yet have a jaw, but sucks its food. It is not a very good swimmer. Its only means of defense is an armor covering its head and part of its body. Its sight allows it to distinguish shadows, and its skin reflects the vibrations of its possible predators. Faced with the astraspis, the Orthoceras reigns over the ocean as a fearsome killer. Being able to measure up to 6 meters or 20 feet long, and weighing more than 1 kilogram or more than 2 pounds, this ruthless and insatiable carnivore is similar to the great white shark as it is feared. It has a cone-shaped shell that contains an air-filled chamber which allows it to float. Although it is feared by many species, the Eurypterid or giant sea scorpion is not afraid of it, and they regularly clash. The Eurypterid is the largest arthropod. It measures 2 meters or 6 feet long and weighs up to 130 kilograms or 290 pounds. A cross between a lobster and a monstrous scorpion, it has a needle-like jointed tail. Its giant claws are sharp and allow it to crush and cut its prey. As a true predator, it feeds on invertebrates, mollusks, and primitive fish. Arthropods, small animals of only a few centimeters or a few inches, covered with a very thin carapace, appeared already a few million years ago. During the great biodiversification of the Ordovician, their shells became harder, and they evolved into gigantic marine animals. The horseshoe crab, which was later considered a living fossil, is an aquatic animal that looks somewhat like a crab. It has a gray, brown, or black carapace. It measures up to 70 centimeters or 30 inches and weighs 5 kilograms, almost 11 pounds. Its head, very broad and rounded, contains 2 small eyes at its top. Its abdomen has 6 pairs of sharp spines and ends with a sting. With its 5 pairs of legs arranged around its mouth, it seizes food. The horseshoe crab has a particularity. It has blue blood. It is the copper contained in its blood which gives it this so particular color, whereas the blood of the vertebrates contains iron. It lives mainly on sandy or muddy bottoms of superficial oceanic waters. The horseshoe crab feeds on mollusks, small fish, worms, crustaceans. The corals land in this flourishing ecosystem. They slowly colonize the oceans and build up into coral reefs. The coral is a small animal that looks more like a plant organism, like a flowering tree. It lives attached to rocks, near the surface of warm waters or at the bottom of the sea, sometimes even in cold waters. Corals make a common skeleton, which becomes the basis of a coral reef. This skeleton can be hard or soft, but in the latter case, the corals grow faster. Coral reefs are filled with a myriad of coral species that form an ecosystem. They are home to a wide variety of animal species and serve as a refuge and food supply. Coral, like all animals, breathes oxygen and emits CO2. Except for the deep-sea coral, it is in symbiosis with a microalgae that lives inside its calcareous skeleton. The algae needs light to photosynthesize and transform CO2 into oxygen. All the waste products of the algae are assimilated by the coral, so they provide 80% of their needs. The remaining 20% is plankton that the coral captures with its small tentacles. The coral reefs contribute to enrich the marine fauna of the time. This particularly interesting period for the history of life will, however, be cut short by the first great crisis and mass extinction. The oceans on Earth teem with life, yet 6,000 light-years away a terrible cataclysm is brewing that will bring about the extinction of many species. In the Milky Way, a star at the end of its life explodes into a supernova. A gigantic explosion of gamma rays gushes out as powerful radiation. It is one of the most destructive phenomena that occurs in the universe. The energy released in about 10 seconds is equivalent to that which could be produced by 10 suns. The emitted rays disperse in the cosmos and head towards the Earth at the speed of light. They penetrate the solar system and pierce the asteroid belt. Once arrived at the level of the atmosphere, the destructive rays exterminate the air molecules and blow the atmosphere. The traces of the supernova shine in the sky alongside the sun. The impact of gamma rays has irreversible consequences for living organisms. They destroy 30% of the ozone layer, letting ultraviolet rays invade the surface of the planet. The light increases, becoming 10 times more powerful than in the Sahara. Plankton, the basis of the food chain, is destroyed, and hunger follows for the plankton eaters. Trilobites, which are used to incubate their eggs in surface waters, see their larvae die under the effect of ultraviolet rays. many corals do not survive. The phenomenon extends over the entire surface of the planet. The base of the food chain being compromised, all species of animals are suffering from starvation. A few months later, a toxic atmosphere invades the planet, rich in nitrogen dioxide. A thick layer of haze obscures half of the sun's rays. There is less light and less heat. Temperatures drop to -12 degrees Celsius or 10 degrees Fahrenheit. The survival of many species is then threatened. The nautiloids laid their eggs, but the cold slows down the embryonic growth, and bacteria appear. Some of them see the day anyway, but the world that offers itself to them is chaotic. Food is far from abundant, and living conditions are hostile. They rely on the strength of their shells to shelter in the ocean depths from the effects of the Earth's cooling. As the temperature drops, mobile animals move around and try to find shelter. But corals, sponges, and other brachiopods cannot escape. Their calcium carbonate shells are difficult to form in cold water. They disappear. The generalized cooling of the planet causes an unpredictable climate due to important temperature differences. Strong ocean currents are formed, as well as violent disturbances. A hurricane blows on the Earth. Weakened animals are swept away without resistance. Some find refuge in the turbulent waters. The Orthoceras and its long shell do not resist the storm. The nautiloid can take refuge in the deeper waters while waiting for the lull. The storms follow one another. The corpses pile up on the shore. No predator is there to devour them. The few surviving species are undernourished. Over the years, the Earth continues to cool. A new ice age begins. The snow piles up, then becomes denser, until it builds huge glaciers. These glaciers suck the water from the oceans, which saw their level decrease by several tens of meters. Astraspis proves to be very resistant in the chaos. It follows the retreating sea and acclimates to the cold water. It swallows everything and anything. This facility allows it to continue to feed, whereas others that only feed on a specific prey do not survive if this prey disappears. Thanks to the adaptability of the Astraspis, a new generation of fish is born. This time, the bones and muscles of the gill take on the function of absorbing food. Another animal clings to life, the Eurypterid. It too follows the retreat of the oceans. With the disappearance of the Orthoceras, it has moved up a rank in the food chain. Its smaller size allows it to eat less and to adapt to the food crisis. The decrease of the ocean level draws new landscapes. Reefs appear above the water level. As glaciers continue to evolve, icebergs are forming under the surface of the water, real threats to aquatic habitats. Corals are being violently destroyed. Large areas of marine habitat are now visible on the surface, but are being eroded by the weather. The resilient ones that survive must follow the ocean, even though the habitats are shrinking. The causes of the Ordovician glaciation are not yet certain. If some think that it would be due to the explosion of a supernova near the Earth, this is difficult to prove because the traces of the latter have long since disappeared. Other hypotheses submit the idea of a sudden fall of CO2 due to the explosion of plants on the surface of the Earth, leading to a global cooling. The only thing that is certain is that the Ordovician glaciation was responsible for the disappearance of many species. This event caused the extinction of 50% of genera and 85% of species. 500,000 years after the extinction began, the Earth warmed up and the glaciers began to melt. Survivors must adapt to this new upheaval. Species that are widely distributed across all continents are more likely to survive. The Orthocera, although in bad shape, is still around. It is weakened, smaller, and becomes a prey. The Eurypterid becomes a formidable predator. The roles are reversed. The Eurypterid adopts new behaviors. The accelerated drop in sea level has led to the development of lungs in some species. The Eurypterid can now drag the carcass of its prey on the shore. Another evolution is visible in fish, the appearance of jaws. The Acanthodians, scavengers cousins of the Astraspus, are no longer content to wait for the remains to come to them. They tear the flesh right off the carcass. It takes 3 million years for the Earth to calm down. The toll is heavy, but thanks to nature's astonishing form of resistance, life resumes its course. Temperatures rise again. The melting of the glaciers fills the oceans again. This rapid rise is due to the melting of water stored on the continents with a low oxygen content. The ocean is depleted, and the effects are harmful to the biosphere. At the same time, vast marine habitats are being rebuilt that welcome some known species, but also new ones. Acanthodians and Astraspus swim together and begin to venture into lakes and rivers. The Eurypterid grows to the size of a crocodile. It has no more predators. It is him who becomes the most feared. It hunts at a fast speed. The emergence of the first plants from the waters builds, a few million years later, an ideal habitat that encourages the first animals to venture out and finally settle there. These first adventurers are segmented creatures, the ancestors of our millipedes. Because of their chitin covering, they have facilities to move on the ground. At first, they do not stray far from the water's edge, but then they discover that mosses contain moisture and food through plant debris and spores. Although these myriapods are not really millipedes, some of them could reach considerable sizes, up to 2 meters long. Being basically adapted to aquatic life, they had to evolve. They acquire an external skeleton and develop a different way of breathing. Myriapods are equipped with a system of breathing tubes called tracheae. Each tube leads to the side of the carapace and splits into an increasingly fine network that leads to the organs and tissues, even penetrating each cell in order to bring them oxygen. The mode of reproduction of terrestrial life also required some changes. The spermatozoa can no longer move in the absence of water. The male and female then go to meet each other in order to transmit their sex cells. A rather laborious process, but one that bears fruit. These undulating, frisky creatures are prime prey for other species. The animals are gradually becoming more and more resistant to humidity and are continuing their terrestrial adaptation. At the same time, the plants also evolve. The Lapitous Ocean closes between the continents Laurentia, Baltica, and Avalonia, which join together and now form Laurasia. Gondwana is still located in the high latitudes, but the ice cap is less extensive. The climate stabilizes, but it is much warmer than today, with a high concentration of CO2 in the atmosphere. The first plants are simple organisms. They need CO2, light, and water. From 420 million years before our era, plants diversify and develop new functions, allowing the circulation of water and nutrients. This is a decisive period for the sustainable establishment of land plants. Mosses and other primitive species do not have roots. Their vertical stems are born from horizontal stems of the same nature, the stolones, which spread on the surface of the ground. The stolones capture water. However, in some of the drier parts of the world, plants need roots to draw the water they need from the depths. 3 kinds of plants with buried structures appeared 420 million years ago: lycopods, horsetails, and ferns. Each of these new plants has stems inside, which solid vessels allow the water absorbed by the roots to circulate. They acquire a rigidity that allows them to reach significant heights. Green plants depend on sunlight for the synthesis of the substances they need. This evolution of size is then a considerable asset. The smallest plants can remain in the shade and risk dying if they are deprived of light. Lycopods, horsetails, and ferns take advantage of their new vigor to grow and become trees. Lycopods and horsetails are found in swamps and reach heights of up to 30 meters or 100 feet. Some trunks measure 2 meters or 6 feet in diameter. The landscape of the land is changing, with forests being abundant and evergreen. Some species move inland from the swamps to the ferns. The latter have large leaves spread out on the ground in order to capture as much light as possible. The animals are confronted with a change in the configuration of the forests, and this puts at risk certain species which had before access to a large variety of leaves and spores on the ground. Their food sources are now elevated towards the sky. The trunks block out a large part of the light, and the forest floor is depleted of vegetation. Some spaces even remain completely bare. This is how some polypod animals start to climb trees. Cooksonia are the first known plants with vascularized tissues. These plants are small, not exceeding 8 centimeters or 3 inches. They have a stem without leaves, flowers, or roots. Each branch ends in a sporangium, a rounded structure that contains spores. The Cooksonia are attached to the ground with thin ridges. The warm climate is also conducive to the appearance of Rhiniopsida, a vascular plant. It presents axes with ramifications and does not have roots but filaments. It sinks in the substrate, and its aerial axis rise and divide each time in 2 identical axes. Its conductive vessels are grouped in the center and covered with a bark, then with an epidermis with a cuticle and stomata. The aerial axes contain the sporangia filled with spores. 20 million years later, when the Lapitous Ocean closed, a mountain range was built within Laurasia. Under the effect of erosion, the chain is destroyed. The hot and humid climate dissolved the limestone. The rock minerals degraded and turned into clay. Other minerals release iron during their degradation. The iron oxidizes, becomes insoluble, and settles to the bottom of the sea. With time, the sediments harden and form sandstone. They cover gigantic surfaces. It is the continent of the Old Red Sandstone. With the melting of the glaciers, the ocean level rises again. This is a period of great evolution for fish. Jawless fish spread, as well as the first freshwater fish. The aquatic life resumes its course, and the ocean is repopulated. The Sarcopterygians, a group of fish, appear, with, among other, the Panderichthys. This fish has a transitional anatomical structure with that of the tetrapods. Its internal skeleton, made up of fins, reminds of Chiridian members. It measures approximately 1 meter or 3 feet, and its head is similar to that of our current catfish. It has primitive lungs. Graptolites also roam the seas in colonies. These animals resemble coral polyps made of coiled and serrated tubes. These animals are grouped around a stem. They can measure from 2 millimeters to 1 meter or 3 feet in length. Some live on the surface of the ocean and drift with the currents. Others attach themselves to algae on the seafloor. A new fish appeared 375 million years ago, a link in the chain between fish and tetrapods, the Tiktaalik. This bony fish looks like a being that would be a curious mixture between fish and alligator. It has scales and fins with rays like all bony fish, but its rather massive pectoral fins resemble the limbs of the first tetrapods. They are made up of an articulated and rather rigid bony skeleton, which allows the animal to move its body in the lagoons. Its wrists and fingers allow it to support its weight and to move on the ground. Its pectoral fins are covered with large muscles and can flex like a wrist joint. This characteristic allows the Tiktaalik to stop at the bottom of the water and to face the strong currents. It has a powerful rib cage to support its body out of the water. The Tiktaalik ventures on land to hunt for new prey. It has gills, but also primitive lungs. The latter were initially developed not for life out of water, but to adapt to shallow and warm aquatic environments, whose waters are depleted in oxygen. Fish, which today are one of the most primitive forms of life, are then one of the most modern. In some cases, they even take on the appearance of real marine monsters. Placoderms roam the seas. The placoderm is a megapredator that dominates the seafloor from the top of its 8 meters or 26 feet length. It is muscular and armed with a sharp jaw, allowing it to have a varied diet composed of algae, mollusks, and other fish. Its head and thorax are covered with thick bony plates that protect its vital organs during attacks. Its 2 jaws are completely toothless and covered with sharp-edged bones. It is thus able to cut its prey in two. Facing the placoderm, the gigantic Dunkleosteus reaches up to 10 meters or 32 feet in length and 5 tons. This ferocious animal is an outstanding predator. Its jaw, although devoid of teeth, is nevertheless sharp like no other. It crushes its prey and then spits out the parts that are indigestible. Its head is protected by bony plates. The Eusthenopteron is an agile predator which has the particularity to have fins conceived like human members. Its endoskeleton comprises, in the anterior fins, a humerus, an ulna, and a radius distinct, and in the pelvic fin a femur, a tibia, and a fibula. 372 million years ago, the Earth is calm. It is good to live. A warm and humid climate prevails, vegetation abounds, and life proliferates and evolves. Large ferns and trees shape the landscape. Tiny insects inhabit these primitive forests. In the ocean, life in many different forms swarms. The coral reefs extend, and the seabed is a veritable underwater city in which inhabitants have found refuge. Sponges, trilobites, corals, insects, nautiloids remain. fish are then one of the most advanced species. In parallel to this explosion of biodiversity, a cataclysm is preparing, deep in the bowels of the Earth. For even if the planet's surface remains calm, its heart is boiling. A gigantic plume pierces the ocean floor. Very hot gases are expelled from the center of the Earth, and jets of hot water surge with unprecedented force. Underwater landslides occur and destroy the reefs. For millions of animals, it is impossible to survive. Fish succumb to the heat. Volcanic eruptions and lava flows stimulate the activity of the tectonic plates. The ocean floor cracks. A new oceanic crust and new underwater volcanoes are formed. The plume infects the ocean. When the molten lava comes into contact with the seawater, it releases toxic substances. The contamination first affects the new generations. The eggs of the eusthenopterons do not survive in these poisoned waters. Over the years, the released gas, mostly carbon dioxide, invades the Earth's atmosphere. The latter is gradually loaded with greenhouse gases. As a result, the temperature at the Earth's surface increases. The heat of the oceans is no longer redistributed. Previously, the polar cold tried to warm up towards the tropics, and vice versa for the cooling of tropical waters. From now on, the ocean freezes, the currents stop. The water in the oceans is getting warmer. The reefs can't stand it, and neither can the Tiktaalik. His habitat evaporates, but he makes a decision that will allow him to save his skin. He gains the dry land in order to move away from these deadly waters. It is thanks to its anatomy that it can afford this change of habitat. Its respiratory system, half gill, half lungs, makes its life on ground and in the seas possible. It has articulated wrists and a mobile neck, and can move by crawling, or at least by wriggling. At this time, the Earth is less hostile than the sea, and the Tiktaalik discovers a new environment and new sources of food. They fared better than most other fish, who once all the water in their environment had evaporated, found themselves trapped and condemned under the hot sun. 250,000 years after the eruption, the giant plume persists. The Earth is subjected to a high level of carbon dioxide and a sharp rise in temperature. It becomes an ideal ground for the proliferation of plants. It is a real paradise for plants that grow excessively and invade the land. Over the years, the dead leaves fall on the ground and accumulate in mass. They rot and form the first layer of humus. This humus, rich in nutrients, is then carried to the oceans by the rains. The algae feed on it and develop immoderately. To do so, they use oxygen and asphyxiate the aquatic life. The seas become saturated with plants, and the abundant kingdom of animals that remained is dying. A million years ago, eruptions began to hit the Earth. Until then, they had been occurring at sea. But now a gigantic volcano is gathering its forces to erupt, this time on land. The Earth shakes. The air is filled with sulfur. Geysers of lava are spat out by the volcano, several hundred meters high. A cloud of ash forms in the sky, bringing the planet into a terrifying darkness. A black veil hides the light of the sun, and the mixture of the gases gives the sky an orange color. most of the ash dissipates into the atmosphere, but the gases that penetrate the stratosphere can remain there for several years. These gases act as a barrier to the sun's rays and plunge the Earth into a volcanic winter. Temperatures drop sharply. The ocean goes from 32 to 21 degrees Celsius. That is to say, from 90 degrees Fahrenheit to 70 degrees Fahrenheit. The Tiktaalics, who had found refuge on dry land, find themselves confronted with an unknown but invincible enemy: snow. It is cold. Their population will not survive it. As with the last mass extinction, a wide variety of causes, sometimes concurrent and often interdependent, have been proposed to explain the Devonian extinction. In any case, the volcanic winter is ending. The Earth is devastated. The marine fauna is globally affected by this mass extinction. 21% of the families, 50% of the genera, and about 75% of the marine species have disappeared. There are still some building groups in the reef environment that survive as isolated individuals. Brachiopods, cephalopods, and trilobites are experiencing a high rate of extinction. The evolutionary dynamics of the arthropods is nevertheless not curbed. Bacteria and algae fill the void left by the animals that are becoming rare. The environment is similar to that of the Precambrian. The trees which had led to its loss will now contribute to give life to the Earth. They produce more and more oxygen, and slowly the temperatures will increase until they stabilize. The seasons reappear, and life can once again diversify. Panderichthys began a transition to legged evolution a few million years ago. They have curious fins. Fish fins are normally made of spiny rays, which are either rigid or soft and flexible. In both cases, they are exoskeletal pieces that support the non-muscular skin fold of the fin. In Panderichthys, the fins are articulated on only one element, without any other ray. They leave a glimpse of humerus, a radius, and an ulna, then end with a flexible veil covered with scales. It is this famous veil that today gives way to a new structure, the fingers. These fingers would be an abnormal embryonic development of the end of the fins. Usually, the end of the fish embryos forms an apical ridge, which generates the growth of the bony rays of the fin. Once all the rays are formed, the ridge peels off, which stops the formation of new bony structures on the fin and ends in a veil. In the first tetrapods, this famous ridge did not come off, and the bone structure continued on its way, giving shape to the arm, forearm, wrist, and then the phalanges. This is how new forms of aquatic animals appeared: tetrapods equipped with functional gills, covered with scales, feeding on fish, and endowed with limbs with fingers. Initially, this evolution is certainly not an adaptation to terrestrial life, but rather to the muddy environment and cluttered with branches and roots of trees. These very rudimentary legs are similar to a kind of paddle. They are rigid, not very functional, and are not at all adapted to support massive fish. A few million years later, the sea level continues to drop, and the land surface becomes larger and larger. Bodies of water become isolated from each other. Tetrapods are better equipped to live in this new environment. Now equipped with gills and lungs, they are able to move from one water body to another. The Ichthyostega is one of the first vertebrates to have 4 legs. It is a descendant of the long-extinct Tiktaalik. The Ichthyostega lives near rivers, lakes, and marshes. It is forced to go on land to look for food, which explains why its future generations will be more terrestrial than aquatic. Thanks to its long pointed teeth, it feeds on fish, insects, but also small terrestrial animals. It can reach up to 2 meters or 6 feet in length, and 20 centimeters or 8 inches in height. Its skull resembles that of primitive fish, with small eyes located on its dorsal side, which gives it a very good field of vision. Its body is covered with scales, and it has a very strong spine, due to the adaptation to terrestrial life. Although it has some kind of legs, it is rather at ease in the aquatic environment, since its 7 fingers are connected by a membrane. But it is an easy prey for other predators with which it must compete for food, which explains its big step for the dry land. Alongside Ichthyostega, Acanthostega evolves between terrestrial and aquatic environment. With a length of 60 centimeters or 23 inches, it has 8 fingers on each hand. Its stiff-jointed limbs prevent it from bending properly and do not allow it to lift its weight on land. They are more efficient for swimming. It will need further development to be completely comfortable out of the water. It breathes thanks to its lungs and reproduces in water. It has a lateral line that allows it to detect vibrations. 360 million years ago, the Earth is enjoying a relative lull. The average temperature on its surface is 20 degrees Celsius, or 68 degrees Fahrenheit. It is warm and humid in the lower latitudes, although the southern part of Gondwana is covered with ice. Forests and swamps abound, and lush vegetation flourishes. As the plant matter decays, it turns into the black or dark brown sedimentary rock, known as coal. This rapid expansion of plants leads the Earth into an oxygen age. As all plants photosynthesize, the concentration of oxygen in the air increases until it exceeds the current concentration. This hyperoxygenated atmosphere favors the development of arthropods, and even some vertebrates, until they reach disproportionate sizes. The anatomy of arthropods explains this gigantism. Their open circulatory system allows their blood to circulate freely in the body cavities, bathing the organs, and not inside vessels. Their body is covered with small openings, the spiracles, which allow oxygen to reach the circulatory system. Oxygen then diffuses into the tissues through small tubes, the tracheoles. Variations in the concentration of atmospheric oxygen will thus have an impact on the size of arthropods. The Earth's tectonic plates continue their movements. Laurasia, which includes Laurentia, Baltica, and Avalonia, collides with Gondwana, which includes all the other land masses. Middle Europe emerges as high mountains. The Appalachians slowly rise in North America. A new supercontinent, Pangea, begins to form. The latter includes almost all the existing continents, except Siberia for a while. A new generation of plants appears, whose sexual generation lives at the top and no longer at ground level. Among them, the cycads. Dressed with large rough fronds, cycads look like ferns. Some plants produce spores spread by the wind. Others produce larger ones, which remain fixed to the mother plant. They evolve in conical thallus, in which ovules are differentiated. When a spore is carried by the wind in the thallus, it germinates and forms a long tube, which digs its way in the female cone. Once completed, a sperm is produced, looking like a majestic sphere that can be seen with the naked eye. It slides down the tube, fuses with the egg, and fertilization takes place. In this time, other plants appear: the conifers with pines, cedars, larches, and firs. The conifers protect their trunks from external attacks by secreting resin. It is fluid and flows from a notch. It is composed of turpentine, and once the turpentine has evaporated, it freezes. The resin then takes on the appearance of a gum, which closes the wound and traps the insects that touch it. The appearance of the amniotic egg is a real revolution in the evolution of species. This egg is that of birds, reptiles, and monotremes. The shell of the amniotic egg is hard and porous. The embryo inside can breathe oxygen from the air, but not from the water. Thus, if an amniotic egg is immersed in water, the embryo dies of asphyxiation. The yolk of the egg is a food reserve sac, intended to feed the embryo, which allows it to hatch at an advanced stage of development. Inside the egg, the embryo evolves in a sac filled with amniotic fluid, called amnion. It is protected from dying out and shocks. Amniote species are totally free of the aquatic environment. At the same time, amniotes develop a dry and relatively waterproof skin, which slows down the water losses. Henceforth, they can move away from the water points and venture towards zones inaccessible until then. Insect wings begin upstream as dorsal blades. They then acquire a circulation. There are 6 of them at this time. Wings confer a significant evolutionary advantage in the world of living things. By mastering the air, these insects become dominators of the land. By flying, the insects move at a crazy speed. They multiply and are the first to reach virgin land, the other side of the river, or the tops of trees. They escape from their numerous predators on the ground, such as spiders, amphibians, or scorpions. But the threat is now coming from among them. The oldest winged insects and the largest airborne predators of this era are the dragonflies. There are many species of them. At that time, dragonflies, like the Meganeura, took advantage of the lack of competition to grow to gigantic sizes, up to 70 centimeters or 28 inches wingspan. But as soon as the air starts to become populated, the giant dragonflies disappear. Dragonflies have 2 pairs of wings articulated with their body. This allows them to move vertically and travel through the air at speeds of over 30 kilometers per hour, or 19 miles per hour. To avoid collisions at such high speeds, they are equipped with sharp senses. Their 2 huge faceted eyes give them a vision of almost 360 degrees and an amazing precision. Dragonflies are daytime shoehorners. Hardly more discreet, the Paleodictyopteron roams the air with its 55 centimeter or 22-inch wingspan. These insects are characterized by mouthparts under the head that allow them to suck sap. A little further down on the ground, the Pulmonoscorpius is a kind of large scorpion that reaches several tens of centimeters. It feeds on other arthropods. Arthropleura likes the abundant vegetation of this time, and it does not pass unnoticed. The genus of millipedes is one of the largest terrestrial vertebrates that ever existed. It measures up to 2.5 meters or 8 feet long and weighs about 50 kilos, that is to say 100 pounds. Its large size repels predators without counting its carapace, which serves as protection. It is herbivorous and thrives in wet and swampy environments. In spite of its cumbersome size, it moves easily on the ground of the forests. It happens to find itself in front of Diplocalus, an amphibian which marks the spirits because of its original anatomy. Indeed, its particularity is its spectacular boomerang-shaped head, much larger than the rest of its body, which gives it a disproportionate look. It measures about 1 meter in length and some 10 centimeters or 4 inches in height, and weighs about 7 kilograms or 15 pounds. It lives between ponds and marshes and can go back and forth between the aquatic environment and the land. It eats fish and small insects. During its search for food, it tries not to cross paths with pelycosaurs for whom it would be an easy prey. Among the best known of this genus, the Dimetrodon is noticed by the large sail it carries on its back. This giant lizard can reach up to 4.5 meters or 15 feet and weigh more than 250 kilograms or more than 550 pounds. It is one of the largest predators of its time. Its sail is made of elongated spines starting from the vertebrae. Its numerous and large teeth allow it to attack many animals: fish, tetrapods, reptiles, amphibians. The presence of insects strongly contributes to the revolution of the plant world that is beginning. The first trees existed in 2 successive forms, sexual and asexual. Thanks to their high size, spores are carried and disseminated easily by the wind. For the sexual cells, the meeting is ensured in the water by the male cells, imposing them to maintain themselves close to the ground. For ferns, horsetails, and lycopods, this mode of reproduction is not a problem. The spores develop into small shoots, the thallus. Once fertilized, they evolve into small plants that will carry the spores. But the thallus on the ground is vulnerable. It attracts animals and dies if it is dried out. In addition to the wind, flying insects help to disperse the spores by moving from tree to tree. The continental block Siberia joins the already welded block of Laurasia and Gondwana. Pangea is now complete. This last collision raises the Ural, a mountain range. The superocean Panthalassa, ancestor of the Pacific Ocean, surrounds Pangea. It takes a C shape with the equator for center and is barred by the Hercynian chain. The ocean that forms in the hollow of the crescent is the Tethys Ocean. The formation of such a supercontinent has repercussions on life. On the continent, the distance of the lands of the center of Pangea compared to the ocean causes a strong decrease in precipitation. Huge deserts are formed in these regions. The aquatic environment is also modified because the length of the coasts having decreased, the surface of the coastal waters also, and consequently, many marine species disappear. Pangea remains a cradle of life, lined with forests, fresh springs, and creatures stranger than the others that are found everywhere. Reptiles adapt to these conditions and develop thermoregulation systems. The therapsids, or mammalian reptiles, take on a new form of protection: fur. This new appearance of reptiles is reminiscent of our current mammals. Therapsids are the prey of an outstanding predator, the terrible Gorgonopsian. This carnivore has overdeveloped canines and incisors, which allows it to attack both small and large animals. It can reach the size of 5 meters or 16 feet long and weigh up to 350 kilograms or more than 750 pounds. Despite the apparent calm and equilibrium that thrives, the bowels of the earth are still boiling. Just over 250 million years ago, in present-day Siberia, a large province called the Siberian Traps was formed. It is under the Earth's crust that everything is played. Gigantic columns of magma are heading towards the surface. Subjected to a strong pressure, the ground spreads out. Cracks appear over several hundred kilometers and miles, as if the Earth was opening in two. Streams of lava flow out of it. Volcanoes eject astronomical quantities of molten rock. In no time, the region is like a huge inferno. The tremors resound on all the surrounding lands. The animals present in the vicinity are immediately burned. The lava flows spread very quickly, and this is only the beginning. The eruption of the Siberian Traps does not stop. That is what distinguishes it from the usual eruptions. It pours its flow of lava for 1 million years. The Earth being at that time formed of a single continent, the ocean of liquid rock spreads everywhere. After about 10 years, the volcanic gases accumulate in the atmosphere. Gigatons of carbon dioxide and sulfur are volatilized, with dramatic consequences for the climate. The carbon dioxide captures heat, and the sulfur obstructs the passage of sunlight. Episodes of cooling and warming follow one another, making life very difficult. Oxygen levels in the air drop, and animals struggle to breathe. Some of them show amazing resilience. Smaller animals are more successful in finding refuge, and those living in communities combine their strength to survive the nightmare. Cold-blooded animals are more resistant to climate change because they can regulate their body temperature. They need less energy to survive. When the basaltic rock bursts out, it transforms, in contact with the air, into solid rock of a deep black. Immense mountains are formed, drawing a landscape of desolation. The living is killed or pushed away, and yet the Earth is not at the end of its sorrows. Volcanic sulfur dioxide mixes with water vapor to form sulfuric acid. Torrents of acid rain are now falling on the planet. The trees are ravaged, and the vegetation is decimated. Shelter is now scarce for the survivors. The warming phases of the planet cause a cascade effect of warming of the oceans. The aquatic environment suffers from a lack of oxygen and threatens the marine species. The methane hydrates present at the bottom of the oceans are maintained in a solid state thanks to the pressure and low temperatures. Under the effect of global warming, these methane hydrates are in their gaseous state and methane is released. This greenhouse gas is 21 times more powerful than carbon dioxide. Vegetation, which usually regulates the proportion of greenhouse gases in the atmosphere, is absent. The warming accelerates considerably. The flora is dying out, suffocated under this immeasurable heat. The base of the food chain is threatened, and famine sets in. The herbivores are the first to be threatened, followed by the species that fed on these same herbivores. In all Pangea, the vegetation disappeared. Life is close to total extinction. Heavy rains carry the dead plants to the ocean. The ocean fills with waste that rots because of the heat. Air and water no longer circulate. the majority of the ecosystems that predominate in the aquatic environment are threatened. Bacteria subsist in this gigantic landfill and produce hydrogen sulfide, a toxic gas when released in large doses into the atmosphere. It is carried all over the surface of the planet by the winds and causes the death of a great number of animals. The Earth has entered a vicious cycle that is killing slowly. 150,000 years after the Siberian Traps eruption began, the lava flow reaches a depth of 1,600 meters, or more than 5,200 feet deep. The lucky few who survive adapt and new generations appear. It is not until 500,000 years after the eruption began that it began to subside. The traps poured more than 6 million square kilometers of lava over the entire surface of the Earth, representing an area equivalent to 2/3 of the United States. The Permian extinction is the most important that the living world has endured. It is 70% of the species that disappeared on the continents. In the oceans, this extinction affects half of the families, 3/4 of the genera, for a total of 95% of the species. Trilobites, reef-building corals, and among others, pedunculated echinoderms are disappearing forever. The tropical paradise has been replaced by a hostile world, and it will take a very long time for the Earth to recover from this catastrophe. Under the effect of plate tectonics, Pangea begins to fracture gently. It is only 50 million years later that rifts begin to separate North America and Africa. Following the formation of this rift, the Atlantic Ocean opens and divides Pangea into two parts, a northern part and a southern part, that will be Gondwanaland and Laurasia. The passage of the ocean near the parts that were previously the center of Pangea humidifies this environment that remained dry and arid until then. From now on, several continental masses are in place, and the oceanic currents are favored. Interactions between terrestrial and aquatic environments increase, and new ecological niches appear. Species are diversifying. Climate change also plays a significant role in the diversification of plants. The Earth is still in remission. It suffered from the last crisis and was emptied of almost all the living things that colonized it. Following this mass extinction, it will slowly recover, and a period of diversification of biodiversity will begin. Nature is surprising, and it has not said its last word. Our journey ends here for today. Are you curious to discover what the Earth looked like 250 million years ago? See you in the next video.